Now, as you can see, we have run 1, run 2, run 3, which is written here run 5, 6, and 7. So we have 3 samples. Again, for reviewing, we have 7 pairs of images here. So we know that the first pair of image, I mean, when I say pair of image, means this is one image, this is second image, okay? This is located at 0.5 coordinates of travel, which means that when the wing moves from right to left, at that location we captured. Again, in the second run, this is again the same location. This is another sample, but of course, the second pair of image is not at the same location as this one it is. Or for example, the third one here is not the same as the fifth one. This is the same location as this one. So if I, for example, show you, this is, for example, see we have some unreliable vectors, okay? Then when I did moving average validation, you can see that. So what we need to do, we need to know that, okay, this is the first moving average validation. This is the first, let's say, vector map that we want to choose for ensemble averaging of 3 samples. So I will choose this, okay, I will choose this one, and this one. So 3 records have been selected. I will click right, new data set. There is a vector statistics. I will click on it. So I will choose all valid non-substituted vectors. So if I click on OK, and if I decrease the level, so you can see that here it is written number of vectors 3, and this is the average of them, okay? So I will do the same thing for the second one. This is, be careful, this is a very important part, 2 with 2 with 2. Click right, new data set, then let me show you here. Can you see some vortex here? If I, you see there is a vortex like that. We will see. Now this third one with third, so it means that the third location, the average of them. Click right, now vector statistics. This is the average of those. So if I want to check it, for example, this is just one of them. If I close other locations, I will show you. This is one run, and this is the another one, and this is the ensemble averaging. So this is the first run, for example. This is the second. So of course they are not same, but now this is the average of them. If we have more data, we can have the average of more data. Then I will show you the rest of it. So number 4, this one with number 4, and I will continue like that for 5, 6, 7 as well. This is 5, 5, 5, because we have here more, let's say, locations. So this is 5, 5, 5. We have more steps in 3. It is very important to be sure that this is 5, 5, and 5. So I chose the correct ones. So I will do that. You see, this is again average of them, and you can see that somehow here, if I decrease the scale, you can see that here we have. You can see that we have a kind of vortex here. If we see, this is the vortex. And let's do for the last two. This is the 3 coordinates of travel, 6, 6, and again 6, new data set, vector statistics, and the 7, last one. So now I have all of them. So the last one is very interesting. You can see that completely the vortex. Now, what you need to do, Dr. Başkan Percin will send you these 1, 2, 3, 4, 5, 6, 7. These are the data that we are going to use. But for instance, for here, you can also calculate them with a MATLAB code or in TechPlot about vorticity. If I click on vorticity, it calculates, and you know it is partial u over partial y minus partial v over partial x. So this is the vorticity, but just we need to click on and check the scale. So say minus 40 to 40, and if I click on 14 levels, so you can see that here we have vortex, here vortex, and these are the trailing edge vortex and vortices. So this is the end of the section. Also we can see about the streamlines. So you can see that streamlines here. So for example, if I click on the 7th one, and if I say that, okay, show me the streamlines, so you can see that here, you see here we have complete vortex, and kind of here we have separation. And if I show you the initial ones, for example, number 1, this is the forming of vortex. Maybe at this location it shows us better. So you can see that more or less we have streamlines. Thank you so much for your attention. Good luck.